Most of us remember the P-51 Mustang as the undisputed king of the skies over Europe, the thoroughbred fighter that broke the back of the German Luftwaffe. It's a story of American grit and ingenuity that many of us grew up with. But what if I told you the Mustang's greatest, most audacious mission, a feat of engineering and raw courage that truly broke an empire's will, took place thousands of miles away, over the very heart of Tokyo? This wasn't just another dogfight. It was a 1,500-mile round trip over open ocean, a journey that Japanese commanders had personally assured their pilots was utterly impossible for any single-engine American fighter. They were wrong, and on the morning of April the 7th, 1945, that brutal miscalculation would come home to roost. We're going to uncover that full story today, and if you appreciate these deep dives into the moments that defined our history, taking a moment to hit the subscribe button helps us keep these incredible stories alive for the next generation. It's a small click that makes a huge difference. Imagine for a moment it's dawn over Tokyo Bay. For the pilots of the Imperial Japanese Army Air Service, it's just another morning in a long, brutal war. They scramble to their cockpits, preparing to intercept the lumbering B-29 superfortresses they know are coming. Their duty is clear: defend the homeland, protect the Emperor. As they climb into the cold, thin air, they see it, the glint of aluminum in the rising sun. But something is terribly wrong. These aren't the heavy, four-engine bombers they expected to face alone. Flying escort, weaving between the giants, are swarms of single-engine fighters, American fighters. For the Japanese pilots, it was like seeing a ghost. Not just any ghost, but a phantom their high command had sworn couldn't exist. These weren't carrier-based Navy fighters, which they knew had limited range. These were land-based Army Air Force P-51s, unmistakable with their sleek fuselages and bubble canopies. They had somehow flown 750 miles from the newly captured island of Iwo Jima, a journey over nothing but hostile, unforgiving ocean. The psychological shock was immediate and devastating. In that single moment, the strategic reality of the war had been turned completely upside down. The sacred home islands, once protected by the vastness of the Pacific, were now within reach. The writing was on the wall, written in the contrails of planes they were told they would never have to fight. Flight. Sergeant Totaro Shimizu, flying a Ki-84 fighter that day, later recounted his utter disbelief. "When we were scrambled," he said, "we were told enemy fighters were approaching. We thought it must be a mistake. When I saw the Mustangs with my own eyes, I thought I was dreaming. Our commanders had assured us no American fighter could reach Japan. Yet there they were, flying as if they owned our sky. In that moment, I knew the war was truly lost." That feeling of dread wasn't just based on surprise. It was based on the machine itself. Because while the Japanese pilots were flying what was arguably their nation's finest fighter, the Nakajima Ki-84 Hayate, they were about to learn a brutal lesson about the difference between a good airplane and a complete weapon system. On paper, the Ki-84, codenamed Frank by the Allies, looked like a worthy opponent. It was powered by a sophisticated 18-cylinder radial engine that could, in theory, produce 2,000 horsepower. In trials, it had proven to be highly maneuverable, even capable of outturning a Mustang at certain speeds and altitudes. It was armed with heavy cannons designed to tear a B-29 apart. So, why was the sight of the Mustang so terrifying? Because the story of this aerial battle isn't just about two planes. It's about two completely different worlds, two industrial philosophies, and the unbridgeable gulf that had grown between them. The secret to the Mustang's impossible journey lay under its hood. It was a masterpiece of Anglo-American cooperation, the Rolls-Royce Merlin engine. While the Mustang's airframe was a marvel of American aerodynamics, its heart was British. Early P-51s, powered by American Allison engines, were decent planes, but they struggled at high altitudes. But when the British strapped one of their legendary Merlin engines into a Mustang, it was like putting a racehorse's heart into a champion runner. The result was an absolute game changer. The version built under license in the United States by Packard, the V1650, was a liquid-cooled V12 engine equipped with a revolutionary two-stage, two-speed supercharger. Now, for those of us who grew up working on cars, a supercharger is a familiar concept. It forces more air into the engine to create more power. But this was a different breed entirely. A single-stage supercharger, like the one in the Japanese Ki-84, works fine at lower altitudes. But as a plane climbs higher, the air gets thinner, and the supercharger just can't keep up. The engine starts to gasp for air, losing power with every foot it climbs. The Merlin's two-stage system solved this problem brilliantly. Think of it like a relay team. The first stage would compress the thin, high-altitude air, and then an intercooler would cool it down, making it denser. Then it would pass that compressed air to a second stage, which would compress it even further before feeding it to the engine. It was like giving the pilot a fresh set of lungs at 30,000 feet. While Japanese engines were starving for oxygen, the Merlin was breathing easy, delivering sea-level power in the thin air where the B-29s flew. This technological marvel gave the P-51D a top speed of nearly 440 miles per hour at 25,000 feet, and a service ceiling of almost 42,000 feet, altitudes where Japanese fighters simply couldn't compete effectively. But speed and altitude were only part of the equation. The other was an almost unbelievable endurance. The Merlin was remarkably fuel efficient for its power, and when combined with the Mustang's groundbreaking laminar flow wing design, a shape that cut drag by over a third compared to conventional wings, the P-51 could sip fuel. With two external drop tanks, each holding 110 gallons, the Mustang could routinely fly for 7 or 8 hours, covering 1,500 miles. It was this combination of brute force at altitude and long-legged endurance that made the impossible possible. And behind every single one of those engines and airframes was the full, earth-shaking might of American industry. The story of the Mustang is also the story of the American production line. While Japan struggled to build a few thousand of its best fighters, America was churning out Mustangs at a rate that defied belief. At peak production in the North American aviation factories in California and Texas, a brand new P-51 rolled off the assembly line nearly every hour. By the end of the war, over 15,000 Mustangs had been built. The D model alone accounted for more than 8,000 aircraft. That's more than the total number of all fighter types Japan managed to produce in the last 2 years of the war combined. And crucially, every single one of those 8,000 Mustangs was built to the same exacting standard. The parts were interchangeable. The performance was predictable. A pilot could be pulled from one squadron, fly a plane he'd never seen before, and know exactly how it would handle. This wasn't just manufacturing. It was a philosophy. It was the belief that quality and quantity could and must go hand in hand. Now let's look at the other side of that coin. What was happening inside Japan's factories? While the Ki-84 Hayate was an excellent design, its execution was crippled by a nation on the brink of collapse. Japan had gambled on a short, decisive war. By 1945, that gamble had failed, and its industry was paying the price. The advanced Nakajima Homar engine in the Ki-84 required incredibly precise manufacturing tolerances, using high-quality steel alloys that Japan simply no longer had. The constant B-29 bombing raids had shattered supply lines and forced production into scattered, sometimes primitive workshops. Quality control, once a point of national pride, had all but disappeared. The result was a mechanical nightmare. Pilots never knew what they were getting. One Ki-84 might perform, as advertised, a true world-class fighter, but the next one off the line could have an engine that would seize up at high power, or landing gear struts made from improperly heat-treated steel that would buckle on touchdown. Many of Japan's best planes were destroyed not by enemy action, but by simple mechanical failure on their own airfields, killing pilots Japan could no longer afford to replace. The fuel situation was even more dire. While American pilots flew on 100-octane aviation gasoline shipped across the Pacific from refineries in Texas, Japanese pilots were lucky to get 87-octane fuel. Often it was much worse. Desperate, they tried to synthesize fuel from coal, pine tree roots. It took 200 stumps to make 1 gallon, and even the byproducts from making sake. This low-grade fuel ravaged their complex engines, causing detonation that could destroy pistons and cylinders in mid-flight. So you have a beautifully designed aircraft, crippled by poor materials, powered by a high-strung engine, running on what was essentially moonshine. That was the reality for the Japanese pilot in 1945. It's a testament to their courage that they flew at all. But courage alone can't fix a cracked engine block or impure steel. So when those two opposing worlds finally collided in the skies over Tokyo on April 7th, what actually happened? The numbers tell a story of brutal efficiency. The American pilots, flying in disciplined formations, held a speed advantage of nearly 100 miles per hour over the struggling Japanese interceptors. Major James Tapp, who would become an ace with 8 victories, described the scene with cold precision in his after-action report. He noted that the Japanese pilots still tried to use their traditional 3-plane formations, but their coordination was falling apart. They were hesitant, slow to react. The Americans used their superior energy to their full advantage, employing tactics honed over years of combat in Europe. Dive through the enemy formation at high speed, fire a quick, accurate burst, and then use the Merlin's incredible power to zoom climb back to altitude, ready to strike again before the enemy even knew what hit them. The difference in firepower was just as stark. The Mustang's 650 caliber Browning machine guns were a finely tuned instrument of destruction. With nearly 2,000 rounds of ammunition, a pilot could walk his fire onto a target, engage multiple enemies, and stay in the fight far longer. Each .50 caliber armor-piercing incendiary round was a devastating projectile, and the guns could deliver 80 of them per second. In contrast, the Ki-84's cannons, while powerful, carried very little ammunition. A Japanese pilot had maybe a few seconds of firing time before he was empty. And worse, the different ballistic trajectories of his cannons and machine guns made hitting anything beyond close range a matter of guesswork. It's one thing to have a powerful punch. It's another to have the stamina to stay in the ring. The Mustang had both. By the end of that first day, 7th Fighter Command was credited with 26 Japanese planes destroyed for the loss of only 2 Mustangs, a kill ratio of 13-1. And that was just the beginning. Within weeks, as the American pilots grew more familiar with the territory, and Japanese pilot quality continued to plummet, those ratios would climb to 20-1, sometimes even 30-1. But perhaps the most significant difference between the two sides wasn't in the hardware at all. It was in the men sitting in the cockpits. This wasn't just a gap in technology, it was a canyon in training and experience. The American pilot, arriving on Iwo Jima in 1945, was one of the most highly trained military professionals in the world. He typically had between 400 and 600 hours of flight time before he ever saw combat. He had spent dozens of hours practicing gunnery, formation flying, and instrument navigation. He had learned combat tactics from veteran instructors, sometimes flying against captured enemy aircraft to learn their weaknesses firsthand. He was part of a system designed to create not just pilots, but expert aerial combatants. The Japanese pilot he was facing was, through no fault of his own, often little more than a boy in a complex war machine. By 1945, Japan's experienced aces, the veteran samurai of the skies who had dominated the early years of the war, were almost all gone. Their replacements were rushed through a training program that had been gutted by fuel and ammunition shortages. Some had as little as 50 hours of total flight time. They had rarely, if ever, fired their guns in practice. They learned tactics from a manual, not from a mentor. They were being asked to fight one of the most advanced fighter planes in the world, flown by some of the best trained pilots in the world, with barely enough experience to safely take off and land. It was a tragic, hopeless situation. Many viewers tell us that it's this human element of the war, the sheer disparity in preparation, that is the most shocking part of the story. This systemic advantage extended to every facet of the mission. For an American pilot, that 750-mile flight over the ocean was a calculated risk, mitigated by an incredible support network. He had detailed weather briefings from reconnaissance flights. He had accurate maps. He had a reliable radio. And most importantly, he had hope. Stationed along the route were Lifeguard League submarines and PBY Catalina Dumbo flying boats, whose sole purpose was to rescue downed airmen. The psychological comfort of knowing that if your engine failed, there was a chance, a real chance of being picked up, was immense. It gave pilots the confidence to push their machines to the limit. The Japanese pilot had no such safety net. He flew with an unreliable radio, if he had one at all. His maps were often outdated. And if he went down in the ocean, he was on his own. His emergency kit, if he hadn't already eaten the rations on the ground due to food shortages, was a cruel joke. His farewells before a mission were not a formality. They were literal. He did not expect to come back. This grim reality was compounded by the physical toll of the missions. An 8-hour flight, strapped into a cramped cockpit, unable to stand or stretch, dealing with the constant drone of the engine and the bone-numbing anxiety. It was a test of human endurance. Here again, American design philosophy made a life-or-death difference. The P-51D's cockpit was a marvel of ergonomics. The bubble canopy gave the pilot an unparalleled 360-degree view, eliminating the deadly blind spots that plagued so many other fighters. The seat, the rudder pedals, the control layout, everything was designed to reduce fatigue and maximize efficiency. A comfortable pilot is an alert pilot, and in a dogfight, alertness is life. The Ki-84's cockpit was a product of a different philosophy, one that often prioritized performance over the pilot. Visibility to the rear was poor. Controls were awkwardly placed. A pilot might have to take his hand off the stick at a critical moment to flip a switch. It was a difficult plane to fly well, and it was unforgiving of the slightest mistake. Mistakes that tired, inexperienced, and terrified young men were bound to make. The war in the Pacific was ultimately a war of logistics. It was a contest between American abundance and Japanese scarcity. And nowhere was this more apparent than in the skies over Japan. Each VLR, very long range, mission from Iwo Jima was a logistical miracle. 100 Mustangs would burn through nearly 60,000 gallons of high-octane fuel and fire off 250,000 rounds of ammunition. And this was happening day after day. A constant river of fuel, parts, and bullets flowed across the Pacific on Liberty ships, which themselves were being built at a rate of 3 per day. For Japan, the logistical situation was a slow-motion catastrophe. By 1945, there was so little fuel left in the home islands that training flights were all but eliminated. Ammunition was rationed. Entire fighter groups were grounded for a lack of basic parts like tires or spark plugs. Mechanics would cannibalize 3 or 4 broken planes just to get one back in the air. This was the unseen war. The war of maintenance logs, fuel gauges, and supply manifest. And it was a war Japan had already lost. Even nature itself seemed to conspire against them, though it took its toll on the Americans as well. On June 1st, 1945, a day the Mustang pilots would call Black Friday, a force of 150 Mustangs flew headlong into a massive, unforeseen weather front. In the violent turbulence and zero visibility, 27 planes were lost in minutes, almost all to the weather. It was a brutal reminder that these long-range missions were pushing men and machines to the absolute edge of their capabilities. The cumulative effect of all this, the technological gap, the industrial disparity, the training canyon, the logistical collapse, was the complete and utter destruction of Japanese air power and national morale. Captain Yoshio Yoshida, a Ki-84 pilot who survived the war, captured the feeling in his diary. He wrote, "The appearance of American fighters over Tokyo has shattered our confidence completely. How can we defend the Emperor when the enemy's fighters roam freely over the sacred homeland? The sight of those Mustangs, so confident, so numerous, tells us what our leaders will not. The war is lost, and we are simply waiting to die." That was the ultimate achievement of the P-51 Mustang in the Pacific. It wasn't just the impressive kill ratios or the fact that it enabled daylight bombing. It was the psychological blow from which the Japanese military never recovered. It was the visible, undeniable proof, flying in broad daylight over the imperial palace, that their cause was hopeless. By the final weeks of the war, Japanese resistance in the air was sporadic, almost symbolic. The B-29s that dropped the atomic bombs on Hiroshima and Nagasaki flew without fighter escort, not because none was available, but because none was needed. The Mustangs had already swept the skies clean. Today, only one Ki-84 Hayate is known to survive, a silent relic in a Japanese museum. Meanwhile, hundreds of P-51 Mustangs are still flying, their Merlin engines roaring at air shows around the world, a living, breathing testament to a time when American engineering and industrial might came together to create what many still call the perfect fighter. It's a powerful legacy, and if this story of American ingenuity resonated with you, sharing this video is the best way to ensure these legacies are not forgotten. The shock those Japanese pilots felt in 1945 was more than just tactical surprise. It was the dawning, terrifying realization that they weren't just fighting an airplane. They were fighting a system, an entire nation's philosophy of production, training, and innovation, all embodied in that one beautiful, deadly machine. In the end, it was a war of mathematics, and the P-51 Mustang was the final, irrefutable proof. So to sum it all up, the P-51 wasn't just a better plane, it was the product of a system that Japan simply couldn't match, and it delivered the final blow to an empire that had already been brought to its knees.